Next is on the data reduction. Okay, how are we going to pre-process the data? We need to do also the data reduction. So what is the goal of data reduction? It is actually to obtain a reduced representation of the data set that is much smaller in volume, but then it is closely maintain the integrity of the original data, because when we mine the data with a reduced data set, it could be more efficient, and possibly it can produce the same analytical method. Why? Because sometimes a database may store terabyte of data, and then the complex data analysis may take a very long time to complete the mining of the data set. So we need to reduce it from terabyte to a lower value, so that the mining of the data can be more efficient. So in data reduction strategies, there are 4 strategies. Number 1 is data cube aggregation. The second one is the dimensionality reduction, numerosity reduction, and also discretization and concept of hierarchy. In data cube aggregation, okay, this is example of it. Okay, for example, we reduce the data from many attribute into one attribute. For example, you have here the data set here. In year 1997, you have 4 quarter here. So you can sum it into annual value. Okay, 1 year punya value, 1997 with this total. This one and this one is another data set. So you can aggregate all of this into one data set. Okay. So 1998 will become row for this data set, and 1999 will also be another row. Okay. Next on this attribute subset selection, where you are going to select a subset of attribute only for the data mining. Okay. Why? Because data set for analysis may contain hundreds of attributes, and sometimes these attributes may be irrelevant or redundant to the task. Okay, so feature subset selection will reduce the data set by removing such attribute. Okay, and retain the only important attribute. So the methods would be forward selection and also back selection. So there are a few methods here. Stepwise backward elimination. Okay, how are we going to eliminate some subset? Okay, so we start with the full set of attribute, and then we start to removing the worst attribute remaining in the set, and then we combine forward selection and backward selection. We select the best attribute and we remove the worst attribute from the remaining attribute. Also, we can use the decision tree induction and also rough set theory. In terms of redundant versus irrelevant attribute, redundant attribute meaning that it duplicate much or all the information contained in one or more attribute. For example, some data set have similar attribute. So when we combine it together, we don't want the column of that. For example, purchase price ni ada dalam column data set 1, and then purchase price tu pun juga dia ada dalam data set number 2. So when we combine, it will become redundant. So we need to merge the data from here, okay, to become just one column. Irrelevant attribute, okay, we can remove the irrelevant attribute here. Macam for example, irrelevant attribute is the attribute that contain no information that is useful for data mining task. Example, student ID is often irrelevant for predicting the student's GPA, or student name. Name or your ID is not necessary will give the value of your CGPA. So it is irrelevant. Things that is relevant, possibly your test, for example, and then your hour of study, and then your what they call that marks of assignment, and then your previous CGPA, for example. But then names or ID will not give any perubahan kepada your student GPA. Then data compression. We have another methods of strategy of data reduction, that is data compression, where we compress the data. For example, the simplest version, the simplest example of data compression is image. For example, if you send the image to your friend using WhatsApp or any application, compare it with Telegram. WhatsApp will compress your image, but then Telegram will retain the size of the image. But then in WhatsApp, even though the image has been reduced, or even though the image has been compressed, it still retain the value of it without any loss of information. So two methods of data compression would be wavelet transforms and also principal component analysis. So you can do further research on this. For possibly you can apply this for your project as well. Then numerosity reduction is to reduce the data volume by choosing alternative, smaller form of data representation. You can use parametric methods, non-parametric methods, and also the techniques is similar to the data cleaning techniques. So histogram has been covered in data cleaning as well. Clustering and sampling. Okay, in sampling, meaning that we allow mining algorithm to run in complexity that is potential sublinear to the size of data. So we choose a representative subset of the data. For example, if we use simple random sampling, we may have poor performance of the present of the skewed. So we do the stratified sampling, where we approximate the percentage of each class in the overall database and then use in conjunction with skewed data. Okay, these are the types of sampling. So usually we use sampling without replacement and also stratified sampling. So in sampling without replacement, each item is selected and it is removed from the population. If in stratified sampling, we use split the data into several partitions, then draw random sample from each partition. So these are the example of sampling. This is an example of stratified sample. So for example, we have here total of our data is 1, 2, 3, 4, 5, 14 data, 14 sample, yeah, 14 tuples. So we sample each to become 1, 2, half, 7, 50%. But in order for us to have these 50% values of sample, we need to reduce for every class, for every value must be 50%. So youth, 50% of youth from 4 must be 2. Middle age from 8 must be 4, and senior from 2 must be 1. So out of 2 data are taken from age youth, okay, and 4 from middle age and 1 from senior. It is based on the ratio for our sampling. But then it is still retain the value of our label here. We still have youth, we still have middle age, and we still have senior. But the value of a tuple is different with the same ratio. So this is hierarchical reduction. And this is the concept of discretization, where in discretization, you are removing the number of values of a given continuous attribute by dividing the range into interval. So, in discretization, there are 2 methods. One is supervised, one is unsupervised. In supervised, you are going to use the class information. Usually, if you have this class label. But then in unsupervised discretization, it does not use the class information. So discretization is used in binning, okay, using unsupervised method, and also entropy discretization. So the concept of hierarchies is to reduce the data by collecting and replacing low-level concept, such as the numeric value for attribute by higher level to by higher level concept. So for example, young, middle age, and senior, you have the hierarchy concept there. And then it can be automatically formed for both numeric and nominal data. So in numeric data, how are we going to apply the concept of hierarchy is by giving the range of value into smaller range, okay? So from 0 to 1000, we give the hierarchy from here, 3 hierarchy. We discretize the value here, reduce the value, okay? And then the concept of hierarchy for nominal data, we must specify the ordering of the attribute, okay, by schema given from the uses of the expert. So for example, in here, the schema of hierarchy is the top level of the hierarchy would be country. Then we have state, then we have city, then we have street. So this is example of it. Concept of hierarchy can be automatically generated, but you have to consider the semantic, okay? So this is the concept of it. So country, if we have 15 country, for sure our province or our state must be double or bigger value than our country. Then similar goes to city and also street. Attribute with the most distinct values placed at the lowest level of hierarchy. So now we have come to the end of our lesson. Okay, so this is the summary. The data preparation is a big issue for both data warehousing and data mining. So data preparation will include data cleaning, data integration, and also transformation. Also, we need to do the data reduction and feature selection to increase the efficiency of mining our data. And a lot of methods have been developed, but this area is actually an active research area, and there's more gaps to be defined. So that's all. Thank you, everyone.